Hello there. Thanks for joining us today. I have had a chance to look over your resume, and it looks like you have a solid 5 years of experience with Angular. We are looking for someone who can not only write code but also lead modules and help us design scalable architecture. To get us started, why don't we keep it simple? From your perspective, what is the primary purpose of an Angular component?
Thanks for having me. It is a pleasure to be here. To answer your question, I view the primary purpose of an Angular component as the fundamental building block of the entire user interface. Each component is essentially designed to control a specific patch of the screen. It does this by combining a logic class, which handles the data and the behavior, with an HTML template that defines how that data is actually presented to the end user. In my experience leading modules, I have found that the real power of components is that they allow us to break a complex, monolithic page into small, independent and reusable pieces. This makes the codebase much easier to maintain and organize. When you have a well-defined component strategy, it becomes much simpler to scale the application because you are essentially building a library of Lego blocks that can be composed together to create complex views.
That makes sense. Now, since you mentioned scalability and maintenance, let's dive into the architecture. In a large-scale application, how would you personally structure your API interaction layer to ensure it remains reusable and testable?
This is a critical area for any senior developer. To ensure reusability and testability, the golden rule is to decouple the API logic from the components. You should never call the HTTP client directly inside a component. Instead, I implement a dedicated service layer. I typically create a specific service for each feature or domain, such as a user service or a product service. These services are responsible for handling the HTTP requests, and importantly, mapping the raw API responses to strongly typed models or interfaces. This ensures that the component doesn't have to worry about the shape of the JSON coming from the server. To take this a step further for a large enterprise app, I usually implement a base API service. This base service handles the common, cross-cutting concerns like adding authentication tokens to the headers, managing timeout logic, and handling global error messages. By centralizing this, you avoid duplicating the same logic in every single service. From a testing perspective, this structure is a lifesaver. Because the components only depend on the service interface and not the actual HTTP client, we can easily swap the real API services with mock services during unit testing. This means we can verify the business logic and UI behavior of our components without ever needing a live backend server, which makes the test suite significantly faster and more reliable.
I like the mention of the base service for cross-cutting concerns. Speaking of the connection between the logic and the view, let's talk about data binding. Could you explain what data binding is in Angular and walk me through the different types?
Absolutely. Data binding is the mechanism that allows the application to communicate between the TypeScript code in the component and the HTML template. It is what ensures that the data displayed on the screen stays in sync with the data stored in the logic. If the state changes in the code, the view should reflect that, and if the user interacts with the view, the code needs to know. There are 4 main types. First, we have interpolation and property binding. These are one-way bindings where the data flows from the component to the template. Interpolation is the classic double curly brace syntax for displaying text, while property binding allows us to set properties of DOM elements or directives. Then we have event binding. This is also one way, but it goes in the opposite direction, from the template back to the component. This is how we handle things like button clicks or input changes. Finally, there is two-way binding, usually achieved with the ng model directive. This allows data to flow in both directions simultaneously. If a user changes a value in an input field, the variable in the TypeScript code updates automatically. And conversely, if the code updates the variable, the input field updates immediately. In complex forms, however, I tend to be careful with two-way binding to avoid unpredictable state changes.
You mentioned being careful with two-way binding in complex forms. That leads perfectly into my next question. When you are building those more complex forms, what advantages do you find in using form group and reactive forms over the traditional template-driven approach?
That is a great transition. The main advantage of using form group in reactive forms is that the entire form logic is moved out of the HTML template and into the TypeScript class. In template-driven forms, the logic is scattered across the HTML, which can make debugging a nightmare in a large application. With reactive forms, the TypeScript class becomes the single source of truth for the form state. This gives the developer complete programmatic control. For example, I can dynamically add or remove form fields based on other inputs, or listen to specific value changes in real time using the value changes observable. Furthermore, creating complex validation logic is much easier and more robust. Since the validation is handled in the class, it is decoupled from the UI, which means I can write comprehensive unit tests for the form logic without needing to render the DOM. It makes the whole process much more predictable because the data flow is explicit.
Let's shift gears to routing for a moment. I see a lot of developers get confused between router module for root and router module for child. Can you explain the difference and when to use each?
Yes, that is a common point of confusion. The forRoot method is used exclusively in the main app module. Its purpose is to initialize the router and create a single instance of the router service for the entire application. It tells Angular how to handle the top-level routes and determines where the root router outlet should be placed. You only call forRoot once in the entire app. On the other hand, forChild is used in feature modules, especially those that are loaded lazily. It does not create a new router instance. Instead, it tells the existing root router to add more routes to its current configuration. This is crucial for performance and state management. If we used forRoot in a lazy loaded module, we would essentially be resetting the routing state every time a new module was loaded, which would break the navigation history and the app's behavior. By using forChild, we are simply extending the routing table.
And regarding security and access control within those routes, how do you handle that? Specifically, what is a root guard, and can you give me a real-world example of how you've used one?
I think of a root guard as a security checkpoint for the application's pages. It is a piece of code that runs before a navigation is completed, allowing the app to decide if a user is actually allowed to visit a specific route. The guard performs a check and returns a Boolean. If it returns true, the user is let through. If it returns false, the navigation is blocked. For example, in a previous project, I implemented an admin guard. We had a set of administrative dashboards that only users with an admin role should see. When a user attempted to navigate to admin, the guard would check the current user's role stored in the authentication service. If the user was not an admin, the guard would return false, and I would trigger a redirect to a non-authorized page or the login screen. This ensures that sensitive parts of the app remain protected from the client side, although, of course, we always back this up with server-side authorization as well.
Let's talk performance. As an application grows, change detection can become a bottleneck. Can you explain the concept of the on-push change detection strategy and when you would recommend implementing it?
By default, Angular uses the default change detection strategy, which means whenever any event happens in the app, like a click or a timer, Angular checks every single component in the entire tree to see if anything changed. In a small app, that is fine. But in a large-scale application, this can lead to significant performance degradation. The on-push strategy tells Angular to skip the change detection for a component unless one of a few specific things happen. First, if one of the components at input properties changes by reference. Second, if an event originates from within the component or its children. Third, if we explicitly tell Angular to check for changes using the change detector F. I recommend implementing on-push when you have components that render large amounts of data, like a complex data grid or a list with many child elements. By switching to on-push, you drastically reduce the number of times Angular runs its detection cycle. It forces a more disciplined approach to data management, usually requiring the use of immutable data patterns, which actually leads to cleaner and more predictable code overall.
You mentioned directives earlier. To make sure we are on the same page, could you explain what Angular directives are in general and then differentiate between structural and attribute directives?
Sure. At a high level, Angular directives are markers on a DOM element that tell Angular to attach a specific behavior to that element or transform it in some way. They basically let us extend the power of standard HTML by adding custom logic. There are 3 types, although we often group the first 2 together. First, we have components, which are essentially directives with an associated template. Then we have structural directives. These are the ones that change the layout of the DOM by adding, removing, or replacing elements entirely. You can always spot them because they are prefixed with an asterisk, like ng if an ng4. For example, ng if completely removes an element from the DOM if the condition is false, while ng for repeats a template for every item in a list. Then we have attribute directives. These are different because they don't change the structure of the page. Instead, they change the appearance or behavior of an existing element. A common example would be a directive that changes the background color of an element when a user hovers over it. The element stays in the DOM, but its properties are modified.
That is a clear distinction. Now let's go back to the service layer. If you were to create a service, what decorator would you use and why?
I would use the @injectable decorator. This is the standard way to mark a class as a service. The decorator tells Angular that this class can be injected into other components or services through the dependency injection system. It is important to note that the decorator itself doesn't magically make the class a service, but it tells the Angular framework that this class is a provider and that Angular should manage its lifecycle and dependencies automatically.
I want to touch on something more technical regarding data fetching. In an Angular service, why would you use HTTP client GET instead of the native browser fetch API?
While fetch is native and powerful, HTTP client is specifically designed for the Angular ecosystem and provides several massive advantages. The biggest one is that HTTP client returns observables instead of promises. Because it uses RxJS, we get a huge suite of operators. We can easily cancel requests if a user navigates away, retry failed calls with a simple operator, or handle complex streams of data. Doing that with fetch and promises is much more cumbersome. Additionally, HTTP client comes with built-in features that fetch just doesn't have. For instance, automatic JSON parsing means I don't have to call JSON on every response. It also integrates with Angular's interceptor system, which allows us to handle headers, logging, and authentication globally across all requests. Finally, it's much easier to mock and test using the HTTP client testing module.
You mentioned interceptors. Let's follow up on that. Imagine you need to implement logging functionality across multiple services. You don't want to manually pass a logger instance into every single service constructor. How would you approach this?
The most elegant way to do this is by leveraging Angular's dependency injection. I would create a dedicated logger service and provide it at the root level of the application as a singleton. Since it's provided in root, any service or component in the app can simply inject it via the constructor. However, for network-level logging, the best approach is definitely an HTTP interceptor. Instead of adding logging code to every single data service, I would create one interceptor that captures every outgoing request and incoming response. Inside that interceptor, I can log the URL, the payload, the status codes, and any errors. This keeps the business logic in my services clean and ensures that all network activity is logged consistently in one central place without any duplication of code.
That's a very clean approach. Now let's talk about testing. Testing complex services can be a pain, especially when they depend on external APIs. How do you ensure your tests are isolated and fast?
To avoid relying on a real server, I always use the HTTP client testing module. This replaces the actual HTTP backend with a mock system. The key tool here is the HTTP testing controller. With this, I can intercept any request made by the service and provide a fake response on the fly. This ensures the tests are isolated because they aren't affected by network instability or changing data on a dev server. They are also incredibly fast because there is no real I/O happening. When I write these tests, I focus on the different scenarios the service might encounter. I'll write one test for a successful data retrieval, another for a 404 or 500 error, and another for when the API returns an empty response. By manually triggering these responses in the test setup, I can verify that my service handles all edge cases correctly.
Let's move into some more advanced UI performance topics. Can you explain the mechanism of virtual scrolling and how it actually optimizes rendering performance?
Virtual scrolling is a technique used to handle massive datasets. Think lists with thousands of items. If you try to render 10,000 DOM elements, the browser will lag, memory usage will spike, and the page will become unresponsive. Virtual scrolling solves this by rendering only the small subset of items that are currently visible in the user's viewport. It essentially creates a small window of elements. As the user scrolls, the system dynamically swaps the content of those elements or shifts their positions to simulate a long list. To the user, it feels like a normal scroll, but under the hood, the DOM tree remains very lightweight. This significantly reduces the number of change detection cycles and minimizes the style recalculations the browser has to perform, which is where the real performance gain comes from.
I've seen some teams try to integrate Angular with other libraries. Let's say you were integrating Angular with a web component library like LitElement. What advanced techniques would you need to ensure proper data two-way binding and lifecycle synchronization?
That is a complex scenario, because you are bridging the gap between Angular's zone-based change detection and the browser's native DOM event system. For data flowing from Angular to the web component, standard property binding works fine. However, for data flowing back, we have to listen for custom events emitted by the web component. To achieve a true two-way binding feel, I would implement a wrapper component or a custom directive that listens for these custom events and updates the local Angular state accordingly. For lifecycle synchronization, it's vital to use ng after view init. Because web components are upgraded by the browser, the element might not be fully functional the moment the component is initialized. ng after view init ensures the element is actually attached to the DOM and upgraded. If the web component maintains its own internal state, I would recommend using a shared service or a state management store to keep the two frameworks in sync. The biggest challenge here is avoiding infinite update loops where Angular updates the component, which triggers an event, which updates Angular, and so on. You have to be very deliberate about where the source of truth resides.
Just a quick technical check on legacy versus modern Angular. What is the difference between ng-app and router module for root?
They are actually from two different eras of the framework. ng-app was a directive used in AngularJS, which is version 1. Its purpose was to tell the browser where the root of the application started. Router module for root, on the other hand, is a method used in modern Angular, version 2 and above. It is part of the routing system and is used to configure the routes and initialize the router service. So while ng-app was about bootstrapping the entire app, for root is specifically about configuring the navigation system within a modern Angular app.
Got it. To wrap things up, let's go back to the basics for a second. If you were onboarding a junior developer and they asked you the fastest way to create a new component, what would you tell them?
I would tell them to use the Angular CLI. It is by far the most efficient way. You just open the terminal and run the generate component command, followed by the name of the component. I'd explain to them that the CLI is not just a shortcut, it's a productivity tool. It automatically creates the TypeScript file for logic, the HTML template, the CSS for styling, and the spec file for testing. Most importantly, it automatically handles the declaration in the application module, so they don't have to manually register the component, which is where a lot of beginners make mistakes.
That sounds like a great way to mentor a junior. Well, we have covered a lot of ground today, from basic components and data binding to advanced performance strategies like on-push and virtual scrolling, as well as architectural patterns for API services and routing. I feel like I have a very good sense of your technical depth and your approach to scalable design.
I appreciate that. It was great discussing these topics with you. I really enjoy the challenge of balancing high-level architecture with the day-to-day implementation details in Angular.
Excellent. Thank you for your time today. We will be in touch soon regarding the next steps.
Thank you. I look forward to hearing from you. Have a great day.